For the last talk, we have building the nervous system for manned and unmanned testing. Our speaker is Weston Ruth. Weston Ruth leads simulation product development at Anduril, building wargaming, training, and autonomy simulators. A Marine Corps veteran with engineering and business graduate degrees from Harvard, Weston's career has taken him from parachuting with reconnaissance units to developing a video game back-end engine. His mission now is to help warfighters visualize and analyze the kill chain, and to give autonomy engineers the means to develop and test autonomous systems for every mission. Welcome to the stage.
When I was a Marine, confidence was everything. Confidence in your training, your equipment, the Marines around you. And there is no replacement for this confidence, this trust that comes from knowing that you're backed by powerful weaponry, technological superiority, and overwhelming speed. But now we're entering a new age of warfare, an age that's asking the warfighters to have this confidence shaken and tested in new ways. We're asking warfighters to fight and work alongside autonomous systems, machines that act and move and decide at machine speed. And there is no doubt that these platforms augment the capabilities of these warfighters. But the nascency of these platforms introduces uncertainty, and that uncertainty risks eroding trust. So, there is no doubt that unmanned systems will have a part to play in the wars of tomorrow. Secretary of War Hegseth recently stated, "We will power a technological leapfrog, arming our combat units with a variety of low-cost drones made by America's world-leading engineers and AI experts." The War Department isn't just fielding unmanned systems, it's making autonomy a key part of future force design. And so with this in mind, and with the tailwinds that's going behind autonomy, what are the gaps or the issues for making sure that we can build confidence with these warfighters? And there's 3 points that I'd like to talk to you about today. The first is transparency. The second is experience, and the third is planning. So first, on transparency. The issue is that warfighters fail to fully understand what these autonomous systems will do. They can't really fully grok all the different ways that a mission can go or all the different threat environments that an autonomous system might be in, and they don't fully appreciate the full gamut of the possibilities of what is here, and they don't know what they'll do when. So it completely undermines potentially the trust that we want to build here. Then there's the planning piece. The planning piece is, if we don't understand how these autonomous systems will perform, how can we actually know how to effectively employ them as part of our warfighting and planning process? How can we, if we're even reticent to employ them, that's one part, but the other part is, are we actually even going to employ them to their full effect? And then there's the execution piece. And this is really the most critical in many ways, because this is where we start thinking about how we can get warfighters the reps they need with the autonomous systems that they're ultimately going to fight the fight with. We need them to have the muscle memory, the confidence working with the systems that they'll actually be performing the actual mission with. And so what happens if we fail to address these critical gaps? What happens if we fail to address these issues? Well, for one thing, it's going to be very difficult for us to bring autonomy into future warfighting concepts. But for another, it even begs the question of the utility of autonomy if we're not really using it to its full capability. But more importantly, if we don't get this right, we effectively cede technological superiority to our adversaries. Because ultimately, somebody else is going to figure this out, and we won't be ready, and we won't be to the same point that they are. And so with this all in mind, what can we start to do to solve these issues? They're absolutely critical. But I think the simulation community has an important part to play in this mission, because simulation is poised not just to tell the warfighter what to believe, but to allow them to viscerally experience what the fights of tomorrow might look like with autonomy. They can actually start to get reps and experience. They can actually start to plan with these in simulated environments, and they can ultimately start to envision how they use these autonomous systems to full effect. And so the simulation community, though, is also going to have to change its paradigm, because right now we're not meeting muster. And the Army has put it quite bluntly, stating the following, that most existing simulations developed in stovepipes are developed in stovepipes as standalone capabilities. And integration across these tool sets is technically and fiscally challenging. So we need to step up the bar. We need to create a nervous system of simulation. Only by interconnecting simulation throughout the entire warfighting planning process, execution, and debrief portions of an operation, only then bringing simulation to bear on all those aspects can we really start to bridge the gap that forms with this confidence piece and ultimately allows us to fully utilize autonomy and manned and unmanned systems working together to full effect. And at Anduril, this is very much how we appreciate the problem, because we understand viscerally that we must build warfighter confidence, but that we also must field warfighters the latest autonomous systems and the latest technologies to complete their missions. And ultimately, we use a software-centric approach that allows them to have a tight feedback loop. And so today, what I'm going to be doing for you is talking through a hypothetical situation, walking you through this framework of how we can build this nervous system of simulation to really build a tight interconnection between man and machine. And so let's take a step back and set the scene. So what we're going to be doing is we're going to be in charge of an island defense. It's up to us to push back an enemy incursion. We have to defend our coastline, and we need to make sure that we secure critical infrastructure inland. What do we have at our disposal? Well, we have unmanned underwater vehicles, UUVs. We have unmanned aerial vehicles, UAVs. We have loitering munitions. These are all the unmanned assets that we have at our disposal, but we also have a mix of conventional forces that we'll be commanding and controlling as well. So, now that we've set the scene for our operation, let's begin the first act of our story. And this is oftentimes the most overlooked, but the most critical act. And this is where we start to create a shared understanding of the battle space. And we're going to be using simulation to drive that understanding home. Because this is oftentimes where things go awry. Because pulling in all the models, all the behaviors, all the autonomous systems behaviors that we'll be running in our simulation, that can take weeks, months, years of work to pull together. And this is oftentimes relegated to bureaucracy and technological interfaces that don't quite jive together, and it ultimately slows us down. But warfighters are all about tempo. They're all about building momentum, and we need to start building that momentum at this phase where we start building our simulation together. We need to pull warfighters, operations analysts, simulation experts, pull them all into one room and start creating this battle space and this understanding of what this picture might look like, what this operation might look like. And so this means we start saying, hey, all right, let's maybe have our UUVs start to create a picketing line on this coastline. Let's have our UAVs doing long-range reconnaissance missions. Let's have our loitering munitions on standby to strike targets as they start coming inbound. These are the assumptions that we can start making in the tasks that we can start putting in our initial simulation as we create a shared understanding. And by creating this baseline of understanding of how this simulation and how this battle might unfold, that's where we start to build trust. Because now we can start building on this simulation and enter the second act. And the second act is all about course of action development through experimentation. This is where we can start running hundreds, thousands of simulations to better understand the full gamut of capabilities. And this isn't any sort of new concept, but it's one that's imperative for tackling the piece about unmanned and manned teaming, because now we can start chipping away against this transparency issue. We can start showing warfighters the full gamut of what is possible. What does happen if we change the tasking priorities of the targets we're going to be striking with our loitering munitions? What does happen if the enemy incursion comes from one coast versus another and our UUVs are on one mission versus another mission? These are the sort of dynamics and the parameters that we can start tweaking and testing and iterating on with the warfighters. And we can do it not only in little vignettes that are very scripted, but instead we can aggregate large data sets of what is an art of possible. And we can start showing them how all the different branching paths that the autonomy could take under these different threat conditions. And so now we've started to build trust on the transparency piece, and we started to build trust on the planning piece. Because ultimately we're allowing warfighters to choose the most likely COAs, and the COAs that are the courses of actions, the COAs that are most likely to occur and that have ultimately the highest P win for them. And so now we can start entering the third act. And the third act is where it does actually get much more engaging for the warfighter, because now we're talking about wargaming. And we're able to bring all these portions of the simulation. We're starting to build this nervous system up and up more and more as we build the foundation, as we do the COA analysis to bring together thousands of simulations. And now we can start choosing those COAs that are most likely to happen, and we can start doing that wargaming on those COAs and getting warfighters engaged with the actual process of tasking and controlling these assets from an aggregated and strategic view. And I know wargaming is an often conflated and misused term, but in this sense, I'm wanting to push this paradigm of wargaming being relegated to back offices that are stateside and far away from the battlefield. And I challenge us to start thinking about wargaming as a toolkit for the expeditionary commander, because there's no reason we can't allow them to see into the future fight that's about to come. And so with this dynamic, now we can allow them to start tasking assets mid-simulation, trying out new parameters, or rather new behaviors for their autonomous systems. Do we have them go target one thing? Do we have them go do high altitude reconnaissance missions, or do we have them go do lower sweeps to get more granular detail? These are the types of things that they can do during the sim. Or we can even run lots of what-if situations. What if this situation fields this piece of equipment versus this? Or what if the enemy attacks beachhead A versus beachhead B? These are the things we can allow them to interface with and dynamically change as the simulation runs, and ultimately give them the confidence that their planning is robust and that they've robustly built a plan with autonomy in mind. And so now we enter Act 4. And Act 4 is also where we start to think now less on the planning piece, but now more on the experience piece. Because this is where we take all these simulations that we've built before at great speed and at great tempo, and moments before the battle, we're able to actually give warfighters a realistic simulation for the battle to come. This is mission rehearsals on steroids. The day and age of kicking around a can and walking around a rough sand table, those are behind us. We can work with a virtual stand table, allowing warfighters to have really engaging materials that they work with to understand what the mission ahead of them looks like. We can actually get them behind the interfaces that they'll be using to command and control these autonomous systems. Whether it's a tablet or a computer, we can actually have them interface as if they were going to be running through the actual through the actual mission. And this is building experience. This is building the reps that warfighters need to have confidence. And then the most important act, Act 5. And this is where the warfighters truly actually have to go fight the battle. The days of just actually doing all this simulation in a safe room before the actual engagement, that time has ended. The deterrence has not been effective, and the enemy has decided to make true on their threats. And so this is an opportunity for the warfighter to actually engage in the battle with the confidence that we've built them up with over these subsequent phases. But more important than that, it's actually, simulation isn't just going to back off and say our job's done at this point, because Act 5 is where we truly allow them to start seeing into the future, in the moments to come. And this is the real value prop, is that we can start to capture, snapshot the current state of the world and bring that into the simulation. There's no reason that we can't take our common operational picture and all of our understanding of the intelligence and the threats that are available and pull that into the simulation and then immediately start simulating what that battle might look like in the moments to come, and seeing how it might look to have your loitering munitions target those entities that are coming towards your beachhead. Do we save some in reserve, or do we push everything that we've got? These are the things that that can fuel the decision-making process for these warfighters even as the battle's unfolding. And again, tempo, tempo, tempo is imperative for this, because the simulation needs to be running at real time, faster than real time rather, so that we can inform decisions ahead of when they occur. And so, with this, in this hypothetical situation, we've actually been able to inform a lot of these what-ifs, and we've been able to inform a lot of this decision-making. The warfighters were able to snapshot the current state of the world. Turns out there was an incursion from a beachhead that we hadn't originally anticipated, and we were able to run simulations, see what the best prioritization of our targets was, and we were able to go out and execute the mission. And now, at this point, we've turned the tide of the battle, and we've pushed them back. But our fight here as a simulation community does not end. And this is the final act, Act 6. And this is where we start to talk about debriefing. I know debriefing is never the favorite thing you do after a battle successfully won, but it's imperative that we go through this exercise, because now we start to bridge the gap of understanding how simulation has performed in a simulated environment versus the actual real environment, and making sure that we improve our simulation tools to better match reality. Similarly, on the autonomy side, we need to make sure the autonomous systems are better matching the expectations of the warfighters. Did they properly execute the tactics that they were told to do? Did they actually perform to the conditions that we had promised? And so by tightening up this loop that goes throughout all the different acts that we've talked about, all the way to debrief, we've now created a nervous system simulation that's truly self-improving. And this is really exciting, because now we're able to not only improve the warfighter's decision-making process, but we're able to improve the autonomy and the simulation software that we're deploying to these warfighters. And so with that, we've gone through all these different phases of the warfighting planning process and how this nervous system of simulation can help them. And the simulation community has so much opportunity here to truly shape not only the autonomous vehicles themselves, their vehicle specs or the behaviors, but truly shape how warfighters employ autonomy in the future. And the stakes could not be higher. And simulation will have a huge part to play, and I believe Admiral Franchetti recently put it best. We must move rapidly to stay ahead and continuously create warfighting advantages. We must think, act, and operate differently, leveraging wargaming and experimentation to integrate conventional capability with hybrid, unmanned, and disruptive technologies. And so the choice is before us. We either move fast, integrate deeply, and ultimately bridge this gap in confidence between warfighter and machine, or others are going to beat us to it. Because ultimately, we're not just preparing for the conflicts of tomorrow, we are shaping them. Thank you.
Okay, at this time, we're going to open up the Slido if you want to scan your code. I do have one question that came in, so I'm going to read it verbatim. It's a bit rich to hear a product manager say, warfighters fail to understand AI. How is that not just bad design?
Yeah, no, and that's a fair point. And the imperative is not on any lack of the warfighter's capability. It is the fact that the autonomous teams that are deploying these technologies have not made these transparent. So I'll make that clear. It's no fault of the end user. It's rather the fault of the teams that are deploying these technologies. And I think that's what I'm really trying to articulate today most clearly is that it's up to us as a simulation community, as the teams that are putting together autonomous systems and deploying those to warfighters to bridge that gap in transparency. And I hope that was clear today is that ultimately I'm trying to show warfighters through simulation just how powerful these capabilities are by really showing them what we're doing. It's one thing to show like, oh, I've got this behavior tree or I've got this black box solution. Like, I think that's what warfighters are getting now, and that's not meeting the muster. And I'm a warfighter. I was a warfighter myself in a past stage, and I deeply appreciate this problem space and appreciate that warfighters need to be equipped with the information they need to go out against these difficult problems.
Oh, no, thank you. Do we have any live questions from the audience? There is a mic, and I see somebody.
Yes, I have a couple of questions. My name is Diego Tornese from Italy. Which algorithms or frameworks can be implemented to quantify trust calibration between human operators and autonomous systems during simulation exercise? And maybe it's a bit related. What role do explainable AI, XAI, techniques play in reducing uncertainty and improving operator trust during mission rehearsal simulations? Thank you.
Okay, yeah. So I guess so. On your first point, like how do we quantify this? How do we measure this? How do we start making sure that we're actually making systems that are bridging this gap? And actually, one of the most critical teams at Andro, at least, is actually our design team and our user research team. And we have folks who are going on site with customers, making sure that they are able to effectively use the interfaces that we've put before them, that they effectively understand what these autonomous systems will do. And there's a bunch of different ways that they actually approach it. It's very much like a human design-focused approach where they run a bunch of experiments with. I think what I've seen them do is kind of taking inspiration from consumer tech, like A/B testing of like what does one interface look at versus another? Like how do we actually see measurable performance gains in terms of like how quickly they're able to task an entity or task an asset to go and do a certain mission. So I think there's all these kind of different metrics around what is ultimately important for the warfighter. Am I able to make decisions quickly? Am I able to task my entity quickly? Am I able to get feedback from the entity quickly? And these measurable things all start to amount to build confidence. And so I think we ultimately need to think about this from a perspective of like, what does the warfighter care about to build this confidence? Well, I care about success rate in deployment. I care about a time to figuring out how, or time to like deploying and tasking it. And those are the types of things that really start to build confidence for the warfighter. So that's a little bit of like how we're approaching it, and the design team will probably have a myriad of other things in mind on top of that. And then I think for your second question, actually, would you mind just asking one more time what the question was?
What role do explainable AI, XAI, techniques play in reducing uncertainty and improving operator trust during mission rehearsal simulations?
Yeah, sure, I gotcha. Yeah, so I mean, honestly, I think there's varying levels of fidelity that certain end users care about. Some folks want to see every single branch of the decision tree that's being made for the autonomous system. And I think what we found is that by and large, earlier stage of the deployment of the technology, it's necessary to get into that level of granular detail so that it's predictable and understandable in terms of like where are the branching paths, how is the decision matrix unfolding. So I think that's one. But then I think once that trust starts to be built more and more, that level of depth and like that level of maybe even oversaturation of information can start to be pulled back a little bit more. So hopefully that answers your question, but yeah.
So as a service member, you probably learned how to field strip a weapon.
Yeah.
And the way you got proficient at that was doing it thousands of times. How do we put this technology in our warfighters' hands so that they can develop the trust in the technology?
Yeah, absolutely. And I think this is, I think this is what is so beautiful and amazing about simulation is that we don't actually need to have the warfighters go and deploy and actually use physical hardware, which might be expensive or risky to deploy, especially depending on what environment you're in. And instead, they can get all of this experience of working with these systems in a simulated environment. And what's powerful is that, as opposed to a weapon that I'm field stripping and I need that actual gun in front of me to field strip it and service it, instead, for these autonomous systems, much of the actual interaction is happening with like a tablet device or with a computer-based interface. And by having this simulated asset that you're effectively controlling, yes, you won't be able to like see it flying through the air, but honestly, there's kind of sometimes limited value of that. Instead, what's really valuable is being able to go through hitting the series of like tasking and deployment interfaces, hitting the go button, seeing the simulated asset travel on your map, and then going in and seeing it get visual on the enemy before going and attacking it. So by doing that with simulation, we can really get them both the training reps that they need, and this is like, I was literally just working with teams. We brought in some warfighters and we got them behind these tablet devices, and they were able to go and command and control simulated Anduril assets, and that was really effective means for getting them the reps that they needed before they took it out into the field. So, yeah.
Weston, we have a question online. It's a two-part question. What would prevent an adversary to use the knowledge of U.S. forces using Anduril's mechanism of wargaming in order to anticipate their next move? And wouldn't that take away the element of surprise, ultimately lead to both parties going back to square one?
Yeah, I guess an assumption I'm kind of hearing in that a little bit is that somehow this adversary will get into the tech stack or get into the wargaming capability that Anduril is providing. And I think it's important to understand that Anduril ultimately and most commonly from what I've seen is ultimately deploying this technology on the tech stack of the end customer. So if the Marine Corps is deploying this technology, the Army, the Air Force, we're ultimately using their infrastructure to deploy this. So from a protected infrastructure standpoint, I think the cybersecurity lens is kind of protected there. But even on the autonomous vehicles themselves, there's probably this kind of, I guess what I'm kind of getting from this question is a little bit like, well, do you have these generic autonomous systems that are available? Like how could a team not maybe get intelligence on how those will perform? And I think there's something to understand here is that there is a level of customization that can be done with these autonomous systems. And I think even what I was trying to talk about a little bit today was saying, hey, there's opportunities throughout this COA generation and the wargaming for for feedback from the warfighters to be given to the people who are developing autonomy. And that's what we're actually very much doing is actually sitting down with pilots, figuring out hey, how do we want XYZ platform to fight and move alongside you? And so I think there's a lot more nuance to that than meets the eye that makes it so that ultimately there will be a level of unpredictability and making and safeguarding ultimately the momentum and advantage that warfighters have.
No, thank you. Unfortunately, that was the last question. Awesome. So thank you, Weston.
Thank you.
Round of applause. And thank you to all our speakers today. That concludes our Next Big Thing session for today. For now, but there's 2 more sessions later this afternoon. There's quantum computing and training robots.